Hi guys, today in 3.3 we're going to talk about the sum and difference of cubes. Now in your book 3.3 covers a lot of other identities, but the one that you really need to know and the one that's going to reappear in your future math courses and in this course are the sum and difference of cubes identity. So we're going to do an abbreviated version of 3-3 because it does kind of have just some extra tricks in there or just extra kind of fun things, but they don't really pop up. Now, if we do have extra time at the end of the year, we will come back, but really what you need to know from 3.3 are the sum and difference of cubes. What the sum and difference of cubes formulas are they're formulas for factoring a sum of two perfect cubes or a difference of two perfect cubes. So some formulas for factoring a sum or difference of two perfect cubes. Now we've already factored difference of squares. Remember, like this is just a side note. Remember when I had like a perfect square minus a perfect square and that would factor into x plus 2 times x minus 2, that pattern? Well, now we're going to work on a formula for the sum of two cubes or a difference of two cubes. Now, first of all, you need to be able to recognize perfect cubes. Perfect cubes are things that get multiplied by themselves 3 times, and then the result is the perfect cube. So let's make a list of perfect cubes so you can recognize them. And then we'll get started into factoring. So 1 cubed is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is, I believe, 64, but I'm double checking. 4 to the third is 64, yes. 5 to the third is 125. 6 to the third is 216. 7 to the third is 343. And this, we could continue this list on and on forever, but we'll stick with these right now. And if we need any higher levels, we will. So you have two formulas right here. You'll need to add these. We're not really going to prove. We just need to know what this formula is. So I'm just going to introduce you to the two formulas, and then we'll do some examples. So the first formula that I have right here is a cubed plus b cubed. So the first one is a sum of cubes. So if you see a perfect cube added to another perfect cube, this is how it will factor. So let's look at an example. Let's take a perfect cube like x cubed plus another perfect cube is 8. Let's factor that. So I need to know what a and b are. So if a cubed is x cubed, then my a value would be x. And if, hold on, let's write this down. If a cubed is x cubed in my problem, then my then my a would be x. And then if b cubed in this scenario is 8, then b would be the cubed root of 8, which is just 2. So now that I know what a cubed, b cubed, a, and b are, I can just fill in all the blanks. And then the other thing to note is that these signs are always going to stay the same. So you'll always have a plus, minus, plus for the sum, and a minus, plus, plus for the difference. So factoring, that says take a plus b. So my a is x, my b is 2. So that would factor into x plus 2 times a squared. So a is x, which means a squared would be x squared, minus, right here says take the a times the b. So a times b would be x times 2 or 2x, plus the b term squared. B squared is 2 squared, which is 4. And so there it's factored. For the difference of cubes, that's the second formula. It's called the difference Difference referring to subtraction. And that works if you have the term a perfect cube minus another perfect cube. And here's the factoring pattern. So let's say I had x cubed minus 27. X cubed is a perfect cube. 27 is a perfect cube. So my a cubed would be x cubed, which would mean that my a would just be the x. And if b cubed, right here, is the 27, then b would be the cubed root of 27, which is 3. So once you've identified all the a cubes and the a's and the b cubes and the b's, then I can, over to the side, I can factor this out. So it says x cubed minus 27 will factor into the a minus the b. So the a is x minus the b, which is 3, times, then it says square the a, and a is x. So x squared, then plus. Then it says multiply the a times the b. Let's see, a is x, b is 3, so 3x, plus, then it says square the b. So b is 3, b squared would be 9, and it's factored. If you flip in your workbook to page 136, there's a couple examples here. Now, number 9, b squared is not a perfect cube, so I cannot apply. This is not sum or difference of cubes. Not sum or difference of cubes. But number 10 is, because 8 is a perfect cube, x to the 6th is a perfect cube, because if you think of x to the 6th, that'd be like x cubed squared. Right? No, x squared cubed. X squared cubed. Yeah, something had to be cubed there. X squared got cubed, and we'll come back to that. And then y cubed. All right, so let's talk about this one. It is a difference, so I'm going to go ahead and let's just draw a line here. Let's write down my difference of cubes formula. A cubed minus b cubed, and I don't need that parentheses, factors into a minus b times a squared plus a times b plus b squared. All right, so I have to identify my a cubed. So I need to know what gets cubed to get x to the 6th. So I know that a cubed equals 8x to the 6th, which means that a, so I have to think, okay, what times itself 3 times would be 8? It would be 2. Then I want to know what times itself 3 times would be x to the 6th. So I can come down here, something times something times something. It needs to be x to the 6th. Needs to be x to the 6th. So if I put like 1's here, 1 plus, that's not 6. But if I put 2's here, 2 plus 2 plus 2 is 6. Okay, so it's x squared is the cubed root of x to the 6th. Shortcut on that, you can just divide the 6 by 3, the exponent by 3. It gives you the cubed root. And then if the b cubed is y cubed, the b is y. So again, shortcuts on taking the cubed root. Divide 6 by 3, you get 2. Divide by 3, you get 1. All right, so let's substitute in what we know. We know, I'm just copying down the problem, 8x to the 6 minus y cubed factors into, now the a is 2x squared. So 2x squared minus, now I want to find the b. B is y, so 2x squared minus y times, and it says square a. So if a equals 2x squared, a squared, I got to square everything. So 2x squared times 2x squared. 2 times 2 is 4. X to the fourth power. Plus, then I need to multiply the a times the b, so I need to multiply 2x squared times the b, which is y, plus the b squared. So if b is y, b squared would be y squared. And my answer is, this is the factorization. Let's see, then I think we have a couple more examples here. Let's do, or did we just do a minus? Okay, let's do a plus. Let's do 42. I'm going to copy down my sum of cubes rule. I don't need parentheses again. A cubed plus b cubed factors into a plus b times a squared minus ab plus b squared. So then let's go through and identify all the parts. We know that a cubed is 8x cubed. So let's think about what a is. The cubed root of 8 is 2, and the cubed root of x cubed is x. Now if b cubed equals y to the 9th, b, divide the 9 by 3 and you get 3. So now let's factor. 8x, so I would take the a, which is 2x, so 2x, plus the b, which is y cubed, times a squared. So I'm going to square this. 2 squared is 4, and x squared is x squared, so 4x squared, minus the a, which is 2x, times the b, which is y cubed, plus b squared. So I need to square this. So y cubed times y cubed. Add those exponents, y to the 6th. So plus y to the 6th.